Hey guys, so today we will understand how merge sort works. Merge sort. So guys, merge sort is one of the most classical sorting algorithms, and this is based on one of the most important paradigms of algorithm, and that paradigm is called as divide and conquer. Okay, divide and conquer. So first let us understand what divide and conquer is. So basically, let's say if I have got a problem 1, okay, whose size is say n, okay. So divide and conquer strategy is that you divide this problem into smaller problems, okay, into the problems of smaller size. So let's say I divided it into a problem of size n by 2 and another problem of size n by 2. Now once, let's say, this sub-problem somehow magically gets solved. Once this gets solved, I receive its solution, that is solution 1. Okay. This also somehow gets solved. So I receive its solution, that is solution 2. Once I have got solution 1 and solution 2, that means the divide part of divide and conquer is over. Okay. So now I can conquer these solutions and formulate the final solution. So that final part which leverages solution 1 of subproblem 1 and solution 2 of subproblem 2 and does something on top of it to get the final answer is called as conquer. Okay. So this is the very high level explanation of divide and conquer paradigm. Now let's try to correlate this divide and conquer paradigm with our merge sort, that how our merge sort leverages it. So let's say I have got an array of size n. So what I would do is I would break this array of size n into two sub-arrays of size n by 2. Okay. These are two sub-arrays of size n by 2. And let's say somehow this particular sub-array gets sorted magically. Okay. So I receive the sorted version of this. Okay. Now this also gets sorted magically. I receive the sorted version of this. So now finally I need to conquer the two sorted portions. This is sorted 1, this is sorted 2. So now somehow I need to conquer these two sorted portions such that I get the eventually sorted array of the larger problem. Okay. So how do I do that? This conquer thing with respect to merge sort is called as merge procedure. Okay. So what merge procedure does is it receives two sorted arrays and it merges them into final sorted array. Okay. So let us try to understand how merge procedure would actually operate. So if I have an array that contains 8, 7, 6, 5, 4, 3, 2, 1. Now let's say I divide it into two parts, 8, 7, 6 and 5, and the other part containing 4, 3, 2, 1. By the time this problem is solved, this portion has become 5, 6, 7, 8, and this portion has become, by the time this has been solved, 1, 2, 3, 4. Now I need to perform a merge action. So that this gets converted into 1, 2, 3, 4, 5, 6, 7, 8. So how do I do that? So let's learn about merge procedure. It takes in two sorted arrays. First sorted array is 5, 6, 7, 8, and the second sorted array is 1, 2, 3, 4. It takes two pointers I and j. Okay. Both of them are initially pointing to the first element of both the subarrays, and it takes an auxiliary array of size equal to size 1 plus size 2, where size 1 is the size of this and size 2 is the size of this. So since there are 8 elements, I need 1, 2, 3, 4, 5, 6, 7. Okay, so these I and j pointers are positioned in a way that either of them qualifies to be the current element. So whichever is smaller qualifies to be the current element. So since this is the smaller, 1 comes here and I move this pointer. 2 is smaller than this, 2 comes here, I move this pointer. 3 is smaller than this, 3 comes here, I move this pointer. 4 is smaller than this, 4 comes here, I move this pointer. Now this array is over. The moment one of the sorted arrays is over and some elements are remaining in the other, that means all the remnants of that array are greater than all the elements that have been inserted till now. And since this is sorted in itself, it can be pushed as it is in this particular auxiliary array. So it's just a matter of putting them one by one over here. Okay, so I will do 5, 6, 7. So this is what the merge procedure is. The time complexity of this is order m plus n, where m is the size of first sorted array and n is the size of second sorted array, because you can see that every element is getting touched only once. Okay, every element is getting touched and pushed only once. So that is the reason. Now in context of merge sort, let's try to understand how this merge procedure actually operates. So I will take an array, let's say that contains 8, 7, 6, 5, 4, 3, 2 and 1. So first what I do, I divide it into 8, 7, 6, 5 and 4, 3, 2, 1. I will merge once this problem and this problem has been solved. So first this problem will be solved, right? According to recursion, first this branch has to be solved, then only this would proceed. Now to solve this, again I break it into 8, 7 and 6, 5, and then I perform merge. Merge would be performed when this is sorted and this is also sorted. Now for this it gets broken into 8, into 7, and then merge would be triggered. Okay, now see, the moment the two sub-arrays are of size 1 each, no further breaking down can happen. So this is the termination condition. The moment I have reached termination condition, what is termination condition? When both the sub-arrays are of size 1 each. So no further calls happen, merge happens. So merge happens, what would happen? That I take an auxiliary array of size 2, and as I described, I would get a sorted array 7, 8 in that auxiliary array, and then from that auxiliary array I can copy that contents back to here. So if I got a merged auxiliary array like this, I copy this back in the original input. So now this has become 7, 8. So basically this problem has been solved. Similarly, same thing happens here. This gets broken to 6, to 5, and then merge kicks in. The moment merge kicks in, it merges them into an auxiliary array and copies the content back over here. So I get 5, I get 6. Now this merge would kick in, because for this problem the half of this has been solved and half of this has been solved. So the next thing is merge. So it will merge this and this in an auxiliary array, and it would give me 5, 6, 7, 8, which would be copied here, and it would become 5, 6, 7, 8. Same thing that happened for this part would also happen for this part, and this would get converted to something like 1, 2, 3, 4. Once this is sorted, so the merge of this entire thing would happen, and there would be an auxiliary array that would contain 1, 2, 3, 4, 5, 6, 7, 8. This entire thing would be copied here, and I would get the eventually sorted array as 1, 2, 3, 4, 5, 6, 7 and 8. So this is how merge sort operates. So if I have to write the pseudocode for merge sort, it is simple. Merge sort would take in an array, its start index and end index. Okay. As I told you, the termination condition is size 1. So I would make further calls only when the size is not 1. It is greater than 1. So if I is not equal to j, it indicates that there are more than one element. So in that case, first thing I do is I find the mid, which is I plus j upon 2, and then first I call the merge sort for the left portion, which is from I to m. Then I call the merge sort for right portion, which is from m plus 1 to j. Once this portion is sorted and this portion is sorted, I call merge of this sorted portion and this sorted portion, m plus 1 to j. So this is the pseudocode for merge sort. Merge procedure you can easily write on your own, where merge procedure would take in starting and ending of one sorted array, sorted subarray, and starting and ending of second sorted subarray, and merges them accordingly. So now let's discuss about the time complexity. So you can see that at every level the size is getting halved. So how many levels will be there? In the last level, there is only one element, and since this is becoming n to n by 2, n by 4, n by 8 and so on, number of levels would be log of n raised to. And now in each level, how many operations are happening? So in each level, in the last level, okay, in the last level, there are n elements of size 1 each, okay. In the second last level, there are n by 2 elements of size 2 each. In the third last level, there are n by 4 elements of size 4 each. So I can say that at each level, number of elements are n into 1, that is n, n by 2 into 2, that is n, n by 4 into 4, that is n. So how many merges would happen? Number of merges would be equal to the number of elements. So in each level, order n merge operations are happening, and since there are log n such levels, so overall time complexity would be order n log n. Let's also discuss about the space complexity. So since I told you I need an auxiliary array to temporarily merge and store the contents, okay, so what would be the size of that auxiliary array? That would be aux of size n, because at max there would be 2 subarrays of size n by 2, n by 2 each. To merge them, I need an auxiliary array of size n. So that's it. That's about the time complexity and the space complexity. I hope you understood it. That's it.